All right, my mathematicians, we're getting into chapter 2, section 6, which deals with ratios and proportions. So previously, you evaluated percents using proportions, and now we're going to compare ratios as well as solve proportions. So got some new vocabulary for this section. I'm going to talk about ratio, proportion, means, extremes, rate, unit rate, scale, and scale model, and we'll get into those as we touch base on those throughout the lesson. All right, so in this first video, we're going to talk about ratios and proportions. Now, the comparison between the number of restaurants and a number of people is called a ratio. Now, this is what I'm referring to. Ratios allow us to compare many items using a common reference. The table below shows the number of restaurants a certain popular fast food chain has per 10,000 people in the United States. So in the United States, they have 0.433 restaurants for every 10,000 people. And then these other states, that's their rates there. So in the United States, as well as other countries, this allows us to compare the number of these restaurants on an equal reference. So the ratio of x to y, a ratio, is a comparison of two numbers by division. The ratio of x to y can be expressed in three different ways that you see here. One of the most common is as a fraction, x over y. But you can say it in words, x to y, or using x colon y. Those all are ways to represent ratios. So keep that in mind as you work through this section, because you may see them as in different representations, but know that x to y, x colon y, and x over y all represent ratios. So suppose you wanted to determine the number of restaurants per 100,000 people in Australia. Notice this ratio is equal to the original ratio. So if I have 0.349 restaurants in Australia per 10,000 people, I want to know how many I would get per 100,000 people. Well, if you think about it, to keep the ratio the same, I have to multiply 10,000 by 10 to get 100,000. So that means I'd have to multiply the 0.349 by 10 to figure out how many restaurants that would make per 100,000 people. So instead of 0.349 restaurants per 10,000 people, it's 3.49 restaurants per 100,000 people. So an equation stating that two ratios are equal is called a proportion. Okay, a proportion, like we just said, is an equation that states that two ratios are equal. So we can say that 0.349 per 10,000 is equal to 3.49 per 100,000, and we can say that that is a proportion because they are equivalent expressions. All right, so let's determine whether 2/3 and 16/24 are equivalent ratios, right? Yes or no, and justify our answer. So here we want to kind of not come up with an equivalent ratio, but we want to show whether these two ratios are equivalent or not. So what you have to do is see, okay, to get from 16 to 2, you have to divide by 8, or to go from 2 to 16, you have to multiply by 8. Either way you set it up is fine. Well, can you do the same thing to the denominator and it still is true? Well, 24 divided by 8 is 3. So as long as you divide the numerator and denominator by the same number or multiply to get the other ratio and it works out, then you have a proportion. If it doesn't work out, if one of the numbers doesn't work out, then you don't have a proportion, you would write no. So the answer for this one would be yes. Because when expressed in simplest form, the ratios are equivalent. So basically 2/3 in simplest form is 2/3, because it already is in simplest form, and 16/24 in simplest form is 2/3. So same thing there, okay? All right, so let's determine whether each pair of ratios are equivalent ratios and write yes or no for our answer and justify. Go ahead and pause the video and hit play when you're ready. Okay, we're back. So 6/10, if you put it in simplest form, you would divide by 2, So that would be 3/5. And that's not the same as 2/5, which is this one right here. So that's a no. 5/30 in simplest form, you're going to divide by 5. And you get 1/6. That is equal to the other fraction, which is 1/6. So yes, these ratios are equivalent because when expressed in simplest form, they are the same. Okie doke. All right, there are special names for the terms in a proportion. So if I have 0.2 to 1.5 and I say that's equal to 1.2 to 0.9, that's the same as saying 0.2 over 1.5 is equal to 1.2 over 9.0. Okay, now here's how this works. The numbers on the inside are called the means, or it's these two numbers right here. Okay, the denominator of the first fraction and the numerator of the second one. The outside numbers are called the extreme, and they are the first and last terms of the proportion, and that would be the top of the first and the bottom of the second, numerator of the first and the denominator of the second. You see how they make a cross when you set it up as a fraction? Okay, so the means extremes property of a proportion. In a proportion, the products of the extremes is equal to the product of the means. So in other words, if you want to test to see if two ratios are equivalent and therefore form a proportion, you multiply the means and you multiply the extremes, and if you get the same answer, then those two ratios form a proportion. If you don't, they are not a proportion. Okay, so another way to determine whether two ratios form a proportion is to use the cross product, and this was the one you've probably seen. And you see how I mentioned, when you multiply means and extremes with fractions, you're going to multiply them in an x. And if those are equal, then they form a proportion. Okay, and it's the same as multiplying the means by the extremes. So use cross products to determine whether each pair of ratios forms a proportion. So we'll set this up is 2 over 3.5 equal to 8 over 14. Well, if I multiply the means by the extremes, so if I multiply the means and the extremes, so 2 times 14, is that equal to 3.5 times 8? They both come out to 28, so yes, it forms a proportion because the cross products are equal. Now, how about 0.3 to 1.5 and 0.5 to 2.0? Well, if I multiply the means and the extremes, 0.3 times 0.2 and 1.5 times 0.5, I don't get the same answers. So the cross products are not equal, therefore the ratios do not form a proportion. Okie dokie. Here's a couple for you to try. Go ahead and take the cross products there and see what you get, and hit play when you're ready to check. Okay, we're back. So 2A in question is 0.2 to 1.8 equal to 1 to 0.9. So you multiply 0.2 times 0.9, and is that equal? I'm going to put a question mark there because I'm kind of asking the question. 1.8 times 1. Okay, so 0.2 times 0.9 is 0.18, and 1.8 times 1 is 1.8. Now, even though they have a 1 and an 8, the decimal's in a different spot, so they are not equal. So you do not have a proportion because the cross product is not equal. How about 2b? Well, I'm going to do 15 over 36, and is that equal to 35 over 42? So I'm going to multiply 15 times 42, and is that equal to 36 times 35? Well, when I multiply those out, the 16 times 42 is 630. 36 times 35, that's a 5 right there, is 1260. Those are definitely not equal, so these do not form a proportion either. Okay, remember the means, the product of the means has to be equal to the product of the extremes in order for ratios to form a proportion or for the cross products to be equal. Okie dokie. All right, that's it for this one. In the next video, we're going to talk about how to actually solve proportions. We're going to throw a variable in there and see what happens. All right, my mathematicians, we'll see you there.